Hello everyone, I'm Sean, and today we'll be talking about simple applications of AMGM inequality. First, what is AMGM inequality? Let's say we have two positive real numbers a and b. The arithmetic mean, AM, is a plus b over 2, which most of you should probably know. The geometric mean, GM, on the other hand, is the square root of AB. The AMGM inequality states that the arithmetic mean is more than or equal to the geometric mean. Both sides are equal if and only if A equals B. When doing questions about AMGM, we must always check if there exists A and B such that this equality holds. AMGM inequality can also be generalized to more than two positive real numbers as shown here. Here's the first application question. Let x be a positive real number. Find the maximum value of 13 minus x minus 1 over 4x. I'll give you a few seconds to solve it. Okay, let's call this expression S. Remember that AMGM only works for positive real numbers. So in this expression, we can apply AMGM to x and 1 over 4x. By AMGM, x plus 1 over 4x over 2 is more than or equal to the square root of x times 1 over 4x. Now we can shift 2 to the right hand side of the equation. And observe this, the x's in the square root cancel out. This gives us 2 square root 1 over 4, which is equal to 1. Wait, this means that s is more than or equal to 13 minus 1, which is equal to 12. Now hold on. Remember that we need to check if equality holds. So from AMGM, equality holds if and only if x equals 1 over 4x. This means that 4x squared equals 1, implying that x equals half. Hence, our expression S has a maximum value of 12. And equality holds when x equals half. So remember that we should choose our A and B such that the sum or product cancels out to give a constant. Here's the second application question. Let x, y, z be positive real numbers and show that this expression is greater than or equal to 9x squared, y squared, z squared. I'll give you a few seconds to solve it. So for this question, we first try applying AMGM to the first half of the product. By AMGM, this is more than or equal to 3 times the cube root of x squared y times y squared z times z squared x, which is equal to 3 times the cube root of x cubed y cubed z cubed, which evaluates to be 3xyz. Now, we can also do the same for the second half of the product, and we also get it to be greater than or equal to 3xyz. Now, by multiplying both of these equations, we get back our answer. And for both inequalities, equality holds if and only if x equals y equals z. You can verify this on your own for both AMGM inequalities. So one tip we can learn from this example is to choose A and B such that the powers cancel out with the square and cube root, as shown here in this example. Next, we'll look at one common mistake students may make when solving AMGM questions. We'll use this question as an example. Let x, y be positive real numbers, and 1 over x plus 4 over y equals 1. Find the minimum value of x plus y. Now at first glance, we may want to apply AMGM to x plus y, which gives it to be more than or equal to 2 square root xy, and also maybe 1 over x plus 4 over y, which this is greater than or equal to 2 square root 4 over xy. Now wait a minute. The expressions on the right seem to cancel out if I multiply them together. So let's just do that. So I'll get like x plus y times 1 over x plus 4 over y to be greater than or equal to 4 square root of 4 because the xy's cancel out. And this gives us 8. So does that mean the minimum value is 8? Well, that's actually not the case. The problem becomes evident when we try solving the two equality equations for both AMGM inequalities. So now, for the first one, we get that x equals y, and for the second one, we get that 1 over x equals 4 over y, which means that 4x equals y. Now, these two equations have no solutions since x and y are positive. So there is no equality case. So this isn't the minimum value for the expression. So how should we go about solving this question? So instead of applying AMGM to the two expressions, we should first expand their product to get 1 plus 4 plus 4x over y plus y over x. Now notice we can apply AMGM to these two expressions and the product would cancel out. So this is more than or equal to 5 plus 2 square root 4x over y times y over x, which is just 4. And this gives us 9. Now we've got to check if equality holds. Equality would hold if 4x over y equals y over x, which means that 4x squared equals y squared, which means 2x equals y. And we can then combine this with the equation given in the question to get x equals 3 and y equals 6. Hence, the minimum value of x plus y would be 9. So from this example, we can see that using AMGM too many times can cause the equality condition to be unsolvable. Hence, we should try not to use AMGM so many times, and instead expand and simplify terms first. Here's our final application of AMGM, application on terms after rearranging creatively. Let x, y, z be positive real numbers, so that this expression is greater than or equal to 9. So try to think of a way to rearrange the terms so that the sum or product is a constant. I'll give you a few seconds to solve it. Okay, so let's look at the x terms first. If we apply AMGM to them directly, we get x squared plus 2 over x to be more than or equal to 2 square root x squared times 2 over x, which is just 2x. But this can't be simplified further. So how can we actually rearrange it so that the product cancels out? Wait, what if we write 2 over x as 1 over x plus 1 over x? Then if we apply AMGM to the x terms, we get x squared plus 1 over x plus 1 over x to be more than or equal to 3 cube root x squared times 1 over x times 1 over x. And notice the x's actually cancel out. So this eventually just gives us 3. Isn't that amazing? We can do the same for the y terms and the z terms. And by adding up all these inequalities, we arrive at our answer. And note that the equality holds if and only if x equals y equals z equals 1, which you can verify yourself. So in summary, we have learned the definition of AMGM, learned how to apply it directly to an inequality, learned how to apply it on each term in a product or sum, and learned how to apply it after rearranging terms creatively. My 2 tips for using AMGM in MO would be, firstly, rearrange terms and choose the terms you're going to use AMGM on, such that the sum or product becomes a constant, or such that the powers cancel out with the square or cube root. And secondly, try not to use AMGM too many times, otherwise the equality condition can become unsolvable, as seen in our third example. Instead, expand and simplify the terms first before using AMGM. That's all for today's video. Thank you for watching.